So we're solving two variable equations. We'll have two equations of two variables, and we want to know what is the solution to both of those equations. So there are lots of points that could be put into as x and y to this first equation, and there are a lot of points, obviously an infinite number of points that would satisfy this equation. We want to know what is going to satisfy both. So what we do is we look at these and say, guess what? I have a 2x and a 5x, but I have a negative 3y and a positive 3y. So if I add these two equations up, my y's will disappear and I only have to contend with one variable. So let's do that. 2x plus 5x is a 7x. Negative 3y and positive 3y is 0. And then 7 plus 0 is 7. So what does x have to be? So we write that as part of an ordered pair. Okay? Now we just have to figure out what y is. So we can substitute 1 in for either x in either equation. You pick which one you like. 2 times the 1 minus 3y has to be equal to 7. So if I have a positive 2, I'll take it away from both sides. And negative 3y is going to be equal to a positive 5. And then I divide both sides by negative 3. So this is something that we've done in Algebra 1 and in Algebra 2, but now you're likely to see fractions. And if you call that negative 1 2/3 or negative 1.6 repeating, all of them would be okay. All right. Second example. 3x plus 4y equals 11 and x plus 2y equals 5. Unfortunately, if I add these up, no variable will disappear. And I can't subtract them, no variable will disappear. But Ray, what's your suggestion? Okay, so let's take a negative 2 times each of the sides on the second equation. And when we do that, he's setting it up so that we'll end up with a negative 4y that can be added to a positive 4y, and that's going to make them disappear. Okay? So if you want to rewrite them so that they're directly below each other, that's fine. You can skip down and say, okay, here's this will be my negative 2x minus 4y equals a negative 10. Now we're ready to add them up. Okay? So positive 3x and a negative 2x is x. The y's disappear by design, and 11 minus 1 or minus 10 is 1. So once again, our x was 1. It'll be part of an ordered pair, a point that satisfies both of those equations. So we plug it back in, and it doesn't matter which equation you plug it into, but most students will prefer the second one because it's not as, you don't have to deal with quite as big of numbers. So 1 plus 2y equals 5 when we plug 1 in for x. And so 2y has to be 4, and y has to be 2. Okay. So that is the point that satisfies both equations. That's where those two lines will cross. What questions do you have on this slide? All right, feeling good about this one. So there are 3 possible situations that you can run into when you have a system of 2 equations with 2 variables. 1, they can do what the last 2 problems did. They can intersect. Okay? They have one point in common. It's where the 2 lines intersect. The second possibility is that they have no solutions whatsoever because those lines happen to be parallel lines. Okay, Alex, let's put it away, please, sir. Okay. They happen to be parallel lines. And the third one is that they have an infinite number of solutions because they happen to be the same line. They're coincident lines, just disguised. So how this happens, or what we do is when we are solving this, we say, guess what? I want to make my x's go away. So I will take this equation times 2, and the x's will disappear. So I'll end up with a 2x plus a 6y equals 2 times 5 is 10. When I add these two together, I get 0x plus 0y equals 11. Is that a true statement? No. So since it's a false statement, we know that these two are never, ever, ever going to intersect. So there is no solution to that problem because the lines are parallel. Okay, never going to happen. 0 does not equal 11. That's your indication you got this special case. Okay, let's look at the other one though. I don't like to work with decimals. So what can we multiply the top one by to make the x's go away? 4. So if we take this whole equation, both sides of it, times 4, we'll eliminate our x variable. We'll have a 1x. 4 times a half is going to be 2y, right? A negative 2y. So positive times a negative is a negative. And 4 times 1 is 4. Now when we add the two equations up, 0 plus 0 again, is that equal to 0? Yes. So since that's a true statement, 0 equals 0, 5 equals 5, 7 equals 7, then we know that it's going to have an infinite number of solutions because they're the same line. So this point satisfies it, this point satisfies it, this one does, this one does, this one does, and so forth. Okay. What questions do you have about this slide? All right, we're good? Okay, now here's where it's a little different than what you've seen before. This is how we pre-calc it, how we make it a little tougher. We can ask you to solve this system of two equations with two variables. What kind of equation or function is that first one? Linear. Okay, how about the second one? Quadratic. Okay, so visualize that in your mind. A linear function and a quadratic function. How many solutions could they have? They could have two, right? It hits the parabola, the line hits the parabola in two places, right? Could they have one solution? If it would hit it where? At the vertex, right? Okay. Could it have no solutions? It could. Not very likely, but it could. Okay. So we may have two answers here. We may have one answer. We may have no solutions. Okay. Let's try it. I see that I have an x squared and a 3x, so it could be messy if I had to try to eliminate the x's, right? I could multiply the top one by 3 and the bottom one by 2, but I'm also going to have an x squared here, which is the easier variable to eliminate, y's, because I have a positive y and a negative y, right? So let's just add these two equations up and see what we get. So we like to write things in descending powers of x. We'll start with our x squared. I have a negative 2x and a positive 3x. So plus x. Negative y, positive y, gone, right? And then I will have 5 plus 1, which is 6. Now we're left with a quadratic. How do we solve a quadratic? Good. We can move the 6 over and factor. So it will be a negative 6 equals 0. We could complete the square. We can use quadratic formula, but this should be the easiest and quickest, right? What are factors of 6 that subtract to become 1? Awesome. Good. Lots of participation. So x is going to be equal to what? Negative 3. So that's one of our parts of our solution. And x could be 2. That's another half of a solution. Okay? So we'll write our answer as an ordered pair. Now, probably easiest to substitute these x's into this top equation, right? Lots to work with. Okay, so let's pick the path of least resistance and work smart. We're going to put a negative 3 in for x. So negative 2 times negative 3 plus y is equal to a 5. Negative 2 times negative 3, positive 6, right? We have a positive 6 plus y equals 5. What is y? Negative 1. When we plugged negative 3 in, -1 is our solution. Okay. Now we have to find the other half of our other point. So when we plug in 2, we'll have -2 times 2 plus y equals 5. -2 times 2 is, when we bring it to the other side, it will become 9. So when x was 2, y is 9. So that is what that looks like. We had a parabola opening upward. Didn't quite look like a parabola in vertex form or what have you. We had a parabola opening upward, and it intersected our line at the point 2, 9, and at the point -3, -1. Make sense? Okay. So, questions on this slide? Good? All right. I'm sorry? Okay. So, how many people have seen the interview? Okay. Tell me a little bit about it. Comedy, romance, horror film. Okay, so it's a comedy, right? Had a lot of press, okay, related to it. What was the topic of the comedy? North Korea, okay? What do we know about North Korea? Communist nation, right? Okay, and this was poking fun at their leader, wasn't it? Okay, so certain groups threatened that there would be bombing, violence, you name it, in theaters if it was shown. So Sony wisely said, rather than cause problems, let's release this straight to video. Okay, so many of you, if you've seen it, you didn't see it in the theater, you actually saw it in videos in some format. So what this particular article was from the New York Times was just a real quick snippet. The interview generated $15 million in online sales and rentals through its first 4 days of availability. So basically saying pretty popular video, right? Sony Pictures said on Sunday at that time that Sony did not say how much of that total represented $6 digital rentals versus $15 sales. But the studio said there were about 2 million transactions overall. So we have enough information there in that story problem to figure out how many rentals transactions there were and how many sales transactions there were. Okay. So how many transactions did we have? 2 million. Okay. Is everyone okay if we let R be the rentals and S be the sales? Okay. So R plus S is 2 million. Okay. So that's how many transactions there were. Now let's talk about money. Okay. How much was a rental? $6. So $6 for every rental. How much for sales? $15 per sale. How much money did they make? 15 million. So we see a big scary story problem and we think, oh my goodness, I can't do this, right? But we just have to find the numbers, make sure there are no distractors, right? And then set up 2 equations. So how would we go about solving this? Good. Multiply the top by -6. So if I take this top equation times a -6, I get -6r minus 6s equals negative 2 times 6 is 12 million. It's a big number, right? We add these up. The r's are gone, which is by design. Positive 15s minus 6s, 9s. 15 million minus 12 million, 3 million. And we divide by 9. And what do we get? $1,666,000, right? Something like that? No, 33. 3 divided by 9 is 9 goes into 30 3 times, right? Minus 27 3 times, minus 27 3 times, right? So we're going to have 333,333. Okay, check my mental math there on your calculator to make sure I did that right. Okay, so that's how many sales that we had. Okay, so if there were 333,333 sales and 2 million total rentals plus sales, how many rentals would we have? This was 0.3 million. 2 million minus 0.3 million is 1.6 million, right? So my rentals is 1,666,667 if we round it. Okay? Make sense? Questions on this one? So the thought came to me, how many of those sales would Sony have made if there wasn't piracy? How much higher would this be? Okay, because a lot of people like to find a way around the licensing software and make it available online through a BitTorrent website and so forth. So I went to figure out how much piracy costs. Get to the right screen here. And I must have closed my link. So here is our answer, which we found, right? Okay, rentals versus sales. And it turns out that according to Torrent Freak, in just 10 hours, 200,000 people downloaded a pirated copy of the movie. They obviously wanted enough to break the law and download it. And based on the sales versus rental rates, how much did Sony lose to piracy in those 10 hours? So we have 83% of those were the rentals, right? And 16.7% were sales. So if we take 83% times the 6 times the 200,000, they lost $996,000 in the rentals, and they lost $510,000 in the sales. Okay, so $500,000 in sales and almost $1 million in rentals. So you're looking at $996,510 lost in just 10 hours of revenue. So what I did was I said, guess what? Of our 2 million sales, 166,000, 1.6 million were rentals. Okay, so that's 83%. And then a third of that, a third of a million, or 17%, were our sales. So if I take my sales amount times the 17% of that times $15 per sale times the 200,000 people that had downloaded it instead of buying it, that's $510,000 that they lost from sales. And if I take my 83% of my total times the $6 that we used to would have gotten from rentals times the 200,000 people who stole from Sony, and that would have been $996,000. So you add the two up, and it's $996,510 that they could have made in sales or rentals in that 10 hours. So we have a company that spent $44 million on production. In 4 days, they had a release total of $15 million, and they lost $1 million in the first 10 hours of piracy. And then if you actually look further, I went back to Torrent Freak to find out how bad it was even later. And after day 4, they had 15 million, approximately 2 million transactions. After day 13, $31 million was how much Sony brought in, 4.3 million transactions. And so they're still, after 13 days, haven't broken even on their movie. But Torrent Freak reported that after 20 hours, they had over 750,000 people who downloaded that video and basically didn't pay for it. After 2 days, that number had hit 1.5 million people. So think about how much money just in one movie. That's one movie that wasn't a super popular movie, right? But that's how much piracy cost Sony with this one movie. So anyway, I think it's kind of interesting because they say it's a problem. I didn't know how much of a problem. Okay, so sorry to take us off on a little jaunt, but this is going to be your assignment. Just 2 problems like those parabola problems. Where does the parabola and line intersect? So those are from section 7.1, and then a few other problems from section 7.2.